This is section 3.1, and this is on statements and quantifiers. So this is our first section in the chapter on logic and truth tables. So the first thing up is a definition of what a statement is. Now you probably think from English class that this is just going to be just a declarative sentence. And it is, somewhat. It's a declarative sentence that's either true or false, but not both. Okay? Now, here's what this means. Things like commands, opinions, questions, and exclamations are not considered statements. So let's look at these examples and let's label each one as a statement or not a statement. So remember, a statement, a lot of people mistakenly think that a statement is something that is a declarative sentence that's true. Okay, but it's not. It can be true or false, but not both. Okay, so that's important. So let's start off. The dog is black. All right, it's a declarative sentence, and it's either true or false, right? It's not a command, it's not an opinion, it's not a question, it's not an exclamation. So this is considered a statement. The dog can juggle. Now you might say, well, that's false, so it's not a statement. Well, no, it's still considered a statement because a statement can be true or false. So even though, I don't know, maybe you do have a dog that can juggle, but even if it's false, it's still considered a statement. The next one, can your dog sit? All right, this one's pretty obviously not a statement because it's a question. So a statement has to be a declarative sentence. So because it's a question, it is not a statement. So right there, boom, not a statement. So the question mark is what makes this not a statement. All right, how about the dog is cute? That sounds like it's going to be a statement, but it's not because it's an opinion. Right? This is one of those situations where, up here it says it's either true or false, but not both. This is one where two people might come to different conclusions. Somebody might look at a dog and say, oh, that dog is so cute. And somebody else may look at it and say, that dog is uglier than homemade sin. Okay, so it's more of an opinion. So it's not a statement. So remember, anything in this list makes it not a statement. Six plus 3 equals 9. You might not think about a mathematical equation like this as being a statement, but it is. It's a declarative sentence, and it's true. So there you go. Statement. 5 times 3 is 100. Now remember, just because it's a false statement doesn't mean it's any less of a statement, okay? It's a false sentence here. It's still a declarative sentence. It's either true or false, but not both. That's false, but it's still a statement. All right, last up, take your phone with you. This one is a command. So that makes it not a statement. Okay, so just kind of going out here, this one was a command. That's what made it not a statement. This one was a question. That's what made it not a statement. And this one was an opinion. So let me just make those little side notes about what it was specifically about those that made those not statements. Okay, statements can be simple or compound. So a simple statement expresses one idea. A compound statement expresses two or more ideas. Compound statements are joined by things called connectives. So we have this list of connectives here, and I went ahead and threw in negation, even though it's not technically a connective. It just is going to go in this list just so all of your definitions and symbols and stuff are all in the same place. So the first connective is called a conjunction. The key word that we use for this is the word and its symbol is this little up arrow looking thing. What I want you to notice is that this is like a pointy version of an intersection symbol, which we associated with the word and. The next connective is the disjunction, and its key word is or, and its symbol is this V. This is a pointy version of a union symbol. Remember, the intersection was the and the union was the or. Now remember, it was what's called an inclusive or, one or the other or both. Next up, we have a conditional connective. The conditional is associated with the keywords if, then. So if this happens, then this is your result. And its symbol is going to be this one-sided or one-directional arrow. And then lastly, the last connective is a biconditional, meaning it's a two-way conditional, and it's an if and only if. It's a stronger conditional statement because it's a double direction kind of a conditional statement. So it's given by a double direction arrow. And then lastly, this is not a connective, but I'm just putting it in the list with all of the others, just for quick reference. And that's a negation. Its key word is the word not, and we use this little tilde for the symbol. This is going to be very similar to a lot of our set things that we did in the last chapter. So that's why I like doing this right after we've covered sets. Okay, so these connectives, remember, are how ideas are connected. So that means that if we're looking at some kind of statement being simple or compound, we need to look for one of these four connectives. So next up, I'm going to give you some examples, and we're going to label them as either simple, one idea, or compound. Okay, so the first one, math is required to graduate. This is a simple statement. It has one idea to it. As opposed to the next example, math and English are required to graduate. This one is a compound statement. This is a compound statement because of that connective right there. Now we have two ideas connected here. We've got this math and English. If it rains, I will not wash my car. This one's a little tricky because Alex will sometimes use the conditional connective and not put the word then. It'll just imply it. So this is an if-then statement. But Alex just sometimes doesn't write the word then here. So if it rains, then I will not wash my car. So the then, let me just put a happy little thought cloud here. That is just implied to be there. But this is a compound statement. And its connective is that conditional, that if-then. All right, lastly, my sister is a nurse. This is a simple statement. There's none of these connectives being used. You can look for these keywords here, this and, or, if, then, if and only if kind of statements. So that one is a simple statement. All right, let's go on to example 3 here. I want you to label the following as either a conjunction, remember the keyword is and, a disjunction, the keyword is or, conditional is an if-then, or biconditional, if and only if. Now, the reason I put a dot, dot, dot is because there's usually, there's words in between here. So it's if something happens, then this result. Okay, so we're going to label them as one of those following connectives. So the house is cold if and only if the heat is broken. Now, what I would like for you guys to do as I go through these examples is pause the video and see if you can go ahead and guess the answers before I go through it. That's going to be really helpful to see if you know what you're doing ahead of time and, if you get those answers right, rather than just leaving it to me to just tell you the right answers and why. So just think about that along the way throughout this course. Okay, so the house is cold if and only if the heat is broken. So really, we're just looking for these keywords in red here. And there it is, if and only if. So that's a biconditional. So let me grab out a highlighter here. So there, that's what made me say biconditional. B says, I will go to the library or I will go to the park. All right, there's my key word, or, hiding in there, and that's a disjunction. And that's a sneaky one. That's very easy to hide. The and and the ors are really easy to hide in there. Bob and Raoul like musicals. Right? Just like the or, the and can sometimes hide in there when you're not looking. So that is a and, so it's a conjunction. If your battery is dead, then you should charge your phone. This is that if-then statement. So if this thing happens, then this thing should happen. So you got that if-then, so that's a conditional. A lot of the homework is going to be kind of fast, because you're just going to have to pick, is it a statement or not? Is it simple? Is it compound? Is it, which connective is being used here? So some of these are going to be really quick and painless. Okay, let's move into these quantifiers. Words like at least one, or there exists, or each, every, all, some, no, or none. All of these are called quantifiers because they give you some kind of quantity, okay? They are classified into two categories. We've got universal quantifiers that are all or nothing, right? We've got all, every, each, none, no. These are really strong, powerful quantifiers because they really represent all or nothing. Then we have the existential quantifiers. Now, the word existential, if you look in that word, look, the word exist is in there. It just means the existence of something, okay? Or the existence of at least one of these things. So this is a much less strict kind of quantifier. So here we've got, at least one, some, few, most, there exists. These are not as strong as the universal ones. The universal ones are very strong. They're very black and white, right? All or nothing. These are a lot more flaky. They're just like, some, few, So it just means that there's the existence of something. All right, so I'm going to give you some examples, and we're going to label that quantifier as either universal or existential. You can really just refer to the previous list about that and look for the keywords again. So you might want to pause the video and see if you can classify this as universal or existential, and then look at that keyword that made you label it as one or the other. Okay, so the first one, every cat is friendly. So we're looking at this word every. That's an all or nothing. So that every is under those universal quantifiers. That's the word that made me choose universal. Some people climb Mount Everest. All right, so here we've got some. This is not an all or nothing. That's going to be an existential quantifier. So that word is falling under the existential quantifiers. A few people like math. All right, here we go with few, again with the existential, the existence of some people. And then lastly, no one lives in that house. So no one, mostly the no here, but the no one, you might say, well, which one does that fall under? Well, right here, the universal, the all or nothing. So no one being none, right? So that's a universal. Remember, the universal is all or nothing. We have to be careful when we're negating statements with quantifiers to them. The negation of a universal quantifier is an existential quantifier and vice versa. So vice versa just means the negation of a universal is an existential and the negation of an existential is a universal. So to say that a lot less wordy, the negation of all or none, that universal, is some. The negation of some is none. Let me help you out with that because some of that may not make sense. So let's do some examples. All cell phones have cameras. A lot of people will mistakenly try to negate this statement. Say, oh, all cell phones have cameras. And say, oh, well, what's the negation or what's the opposite? You may think about it like that. What's the opposite? And they may say, well, the opposite of all is none. No cell phones have cameras. Well, we don't have to be black and white here, okay? If someone tells you all cell phones have cameras, all of them, and you want to prove that person wrong, you want to negate that statement. If you want to prove this person wrong who says all cell phones have cameras, what do you need in order to prove them wrong? You don't need for every camera to not have a cell phone. You just need to find a camera somewhere, a cell phone somewhere that doesn't have a camera, right? Maybe like one of those jitterbug phones that you see for seniors and something. And it doesn't have a camera on it. So you just have to say, hey, look, here's a cell phone that doesn't have a camera. You're wrong. All of them do not have cameras. So the negation of this all is just the existence of at least one. All right. Now, the way that we're going to say this is some cell phones do not have cameras. So here's my universal quantifier of all. I am negating it with some. And then I have my negation in there, my not, right? I could have just as easily written there's at least one cell phone that does not have a camera. That's just as correct, okay? I'm only writing it like this because the way Alex is going to do these for you is multiple choice, and it's going to give you a bunch of answers to choose from. So I'm writing it the way Alex is going to write it in that multiple choice form for you. So we're writing the negation. We're going to have two parts to this negation. We're going to negate the quantifier, the universal quantifier. We're going to negate it to be an existential quantifier. And we're negating the statement, right? The cell phones have cameras. Cell phones do not have cameras. So it's actually a two-part process. Okay, so some houses are made of brick. This is an existential quantifier of some. So if we want to negate this, we're going to say no houses are made of brick. We don't need to put a not in here because this is taken care of here. There's my negation. I'm negating that existential quantifier right there with this universal quantifier. Some houses are made of brick. If you wanted to prove somebody wrong who said that, you would just have to say, nope, no houses are made of brick. That's the only way that that statement's going to be wrong. Okay, last up. Everyone who passes algebra has studied. Everyone is a universal quantifier, right? It's an all kind of a thing. So the opposite of everyone who passes algebra has studied is the existence of someone who passes algebra who has not studied. So we're going to say some who pass algebra have not studied. So I did throw in that negation, that not, like I did in part A, back in the previous page. Here I didn't need to throw in a not because the no takes care of it for me. Okay, last example. We're going to write the following statements in symbolic form. This is setting us up for the future sections in this chapter where we're going to use truth tables and we're going to use a lot of symbols here. Now, when I say symbolic form, I'm talking about these symbols over here that we talked about. So the conjunction uses this symbol, the disjunction, conditional, biconditional, and negation. So we're going to be using those symbols. Okay. This P with a colon, Q with a colon, and then a statement after it means that I'm going to call this statement, the heater is working. I'm going to abbreviate that statement with the letter P. I'm going to represent this statement, the house is cold, with the letter Q. Okay. If the heater is working, then the house is not cold. So let's dissect this. We have P is the heater is working. So that is statement P. Then we have statement Q, which is the house is cold. We have the word not creeping in here on us. And we've got the connective of if then. Okay, so we're really going to have to dissect this. The if then is the connective that we're going to use between these two statements. Its symbol is an arrow. So my P statement is first. The heater is working. So that statement is first. This conditional if then is going to go right here. So there's my if then. There's my P statement. And it's not just going to Q because we have this not in here that wasn't in my original Q. So I'm going to have to throw in the symbol for negation. So that symbol for that negation, that not, is this little tilde, the little wiggle. This is my final answer. So this is the symbolic form of this statement. We're going to be using this throughout the rest of this chapter. Okay? We're going to be translating statements into letters and connectives into symbols, and then like these negations into symbols, and then we're going to build bigger and bigger statements. The ultimate goal here is to determine things like arguments. Are they logical? Are to make sure that you're saying what you mean, that you make a statement and it's like, okay, is that what you actually mean to say? Or logically, is your statement, wrong? That kind of stuff. If you've ever taken a philosophy class, you may have studied these before in a philosophy class. Okay, last up, the heater is working and the house is cold. Okay, the heater is working. There's statement P. The house is cold. There's statement Q. And we have this and in between them, that conjunction. So I've got the heater is working and the house is cold. So that's my final answer, but I'm just going to add some color on here for your viewing pleasure. Just so you can see why I use those symbols and what words inspired me to use those symbols. So this and, so remember these symbols are coming from back here. I'm not just pulling them out of my butt. The and is a conjunction. It uses this symbol right here. The if then is a conditional. It uses this symbol. The not is a negation. It uses that symbol. Okay. So that is it for section 3.1.